to cable internet is a form of broadband internet access which uses the same infrastructure as a cable television. Like digital subscriber line and fibre to the premises, cable internet access provides network edge connectivity last mile from the internet service provider to an end user. It is integrated into the cable television infrastructure and agnostously to DSL, which uses existing telephone network. Cable TV networks and telecommunications networks are the two predominant forms of residential internet access. Recently, both have seen increased competition from fibre deployments, wireless and mobile networks. Broadband cable internet access requires a cable modem at the customer's premises and a cable modem termination system (CMTS) at the cable operator's facility, typically a cable television head end. The two are connected via coaxial cable or hybrid fibre coaxial HFSC plant. While access networks are sometimes referred to as last mile technologies, cable internet systems can typically operate where the distance between the modem and the termination end is up to 160 kilometers (99 miles). If the HFC network is large, the cable modem termination system can be grouped into hubs for efficient management. Downstream, the direction toward the user, bit rates can be high as 1 gigabit per second. Upstream traffic originating at the user ranges from 384 kilobytes to more than 50 megabits per second. One downstream channel can handle hundreds of cable modems. As the system grows, the CMTS can be upgraded with more downstream and upstream ports and grouped into hub CMTS for efficient management. Most data over cable service interface specification DOCSIS cable modems require strict upload and download rates with customizable limits. These limits are set in configuration files which are downloaded to the modems using the Trivial File Transfer Protocol. When the modem first establishes a connection to the provider's equipment, some users have attempted to override the bandwidth cap and gain access to the full bandwidth of the system by uploading their own configuration file to the cable modem, a process called uncapping. Satellite broadband. Satellite internet access is internet access provided through communications satellites. Modern consumer-grade satellite internet service is typically provided to individual users through geostationary satellites that can offer relatively high data speeds, with newer satellites using Ku band to achieve downstream data streams up to 506 megabits per second. Following the launch of the first satellite Sputnik 1 by the Soviet Union in October 1957, the US successfully launched Explorer 1 satellite in 1958. The first commercial communications satellite was Telstar 1, built by Bell Labs and launched in July 1962. The idea of a geosynchronous satellite, one that could orbit the Earth above the equator and remain fixed by following the Earth's rotation, was first proposed by Hermann Protonik in 1928 and was popularized by the science fiction author Arthur C. Clarke in The Wireless World in 1945. The first satellite to successfully reach geostationary orbit was SYNCOM-3, built by Hughes Aircraft for NASA and launched in August 1963. Succeeding generation of communication satellites featuring large capacities and improved performance characteristics were adopted for use in television delivery, military applications, and telecommunications purposes. Following the invention of the Internet and the World Wide Web, geostationary satellites attracted interest as a potential means of providing Internet access. A significant enabler of satellite-delivered internet has been the opening up of the Ka band for satellites. In December 1993, aircraft co-filed with Federal Communications Commission for a license to launch the first Ka-band satellite. Spaceway. In 1995, FCC issued a call for more Ka-band satellite applications, attracting applications from 15 companies. Among those were EchoStar, Lockheed Martin, GE Americom, Motorola, K-Star Satellite, which later became Wild Blue. Among prominent aspirants in the early-stage satellite internet sector was Teledesic, an ambitious and ultimately failed project funded in part by Microsoft that ended up costing more than $9 billion. Telesat's idea was to create a broadband satellite constellation of hundreds of low-orbiting satellites in the Ka band frequency, providing inexpensive internet access with download speeds of 720 megabits per second. The project was abandoned in 2003. Teletext's failure, coupled with the bankruptcy filings of the satellite communications provider Iridium Communications Inc. and Globalstar, dampened marketplace enthusiasm for satellite internet development. It wasn't until September 2003 when the first internet-ready satellite for consumers was launched by Eutelsat. In 2004, with the launch of Ankit F2, the first high-throughput satellite, a class of next-generation satellites providing improved capacity and bandwidth, became operational. More recently, high-throughput satellites such as Viasat's VIA-1 satellite in 2011 and UNet's Jupiter in 2012 have achieved further improvements, evaluating downstream rates from 1 to 3 megabits per second up to 12 to 15 megabits and beyond. Internet access services tied to these satellites are targeted largely to rural residents as an alternative service to dial-up adsl or classic FSSES. Since 2014, a rising number of companies announced working on internet access using satellite constellations in low Earth orbit. SpaceX, OneWeb, and Amazon all plan to launch more than 1,000 satellites each. OneWeb alone raised $1.7 billion by February 2017 for the project, and SpaceX raised over $1 billion in the first half of 2019 alone for a service called Starlink, and expected more than $30 billion in revenue by 2025 from its satellite constellation. Many planned constellations employ laser communication for inter-satellite link to effectively create a space-based internet backbone. As of 2017, airlines such as Delta and American have been introducing satellite internet as a means to combat limited bandwidth on airplanes, offering passengers usable internet speeds. Satellite internet generally relies on three primary components: a satellite, typically in geostationary orbit, sometimes referred to as geosynchronous Earth orbit or GEO, a number of ground stations known as gateways that relay internet data to and from the satellite via radio waves, microwave, and a small antenna at the subscriber's location, often VSAT, very small aperture terminal dish antenna with a transceiver. Other components of a satellite internet system include a modem at the user end, which links the user's network with the transceiver, with a centralized network operations center (NOC) for monitoring the entire system. Working in concert with a broadband gateway, the satellite operates a star network topology where all network communication passes through the network hub's processor, which is at the center of the star. With this configuration, the number of remote VSATs can be connected to the hub in virtually limitless. Marketed at the center of the new broadband satellite networks are a new generation of high-powered GEO satellites positioned 35,786 kilometers to 22,236 miles above the equator, operating in Ka band 18.3 to 30 GHz mode. These new purpose-built satellites are designed and optimized for broadband applications, employing many narrow spot beams which target a much smaller area than the broad beams used by earlier communication satellites. This spot beam technology allows satellites to reuse assigned bandwidth multiple times, which can enable them to achieve a much higher overall capacity than conventional broad beamed satellites. The spot beam can also increase performance and consequently capacity by focusing more power and increased receiver sensitivity into defined concentrated areas. Spot beams are designed as one of two types: subscriber spot beams, which transmit to and from the subscriber side terminal, and gateway spot beams, which transmit to from a service provider ground station. Note that moving off the tight footprint of a spot beam can degrade performance significantly. Also, spot beams can make the use of other significant new technologies impossible, including carrier-in-carrier modulation. In conjunction with the satellite's spot beam technology, a bent pipe architecture has traditionally been employed in the network, in which satellite functions as a bridge in space connecting two communication points on the ground. The term bent pipe is used to describe the shape of the data path between sending and receiving antennas, with the satellite positioned at the point of the bend. Simply put, the satellite's role in this network arrangement is to relay signals from the end user's terminal to the ISP's gateway and back again without processing the signal at the satellite. The satellite receives, amplifies, and redirects a carrier on a specific radio frequency through a signal path called a transponder. Some proposed satellite constellations is LEOs such as Starlink. Telsat Constellation and LeoSat will employ laser communication equipment for high throughput optical inter-satellite links. The interconnected satellites allow for direct routing of user data from satellite to satellite and effectively create a space-based optical mesh network that will enable seamless network management and continuity of service. The satellite has its own set of antennas and receive communication signals from Earth and to transmit signals to their target location. These antennas and transponders are part of the satellite's payload, which is designed to receive and transmit signals to and from various places on Earth. What enables this transmission and reception in the payload transponders is the repeater system RF radio frequency equipment used to change frequencies, filter, separate, amplify group signals before routing them to their destination address on Earth. The satellite's high gain receiving antenna passes the transmitted data to the transponder, which filters, translates, and amplifies them, then redirects them to the transmitting antenna on board. The signal is then rerouted to a specific ground location through a channel known as a carrier. Besides the payload, the other main component of communication satellite is called the bus, which comprises all equipment required to move satellite into position, supply power, regulate equipment temperatures, provide health and tracking information, and perform numerous other operational tasks. Along with dramatic advances in satellite technology of the past decade, ground equipment has similarly evolved, benefiting from higher levels of integration and increasing power, expanding both capacity and performance boundaries. Gateway, or Gateway Earth Station, its full name, is also referred to as a ground station teleport or hub. The term is sometimes used to describe the antenna dish portion, or it can refer to the complete system with all associated components. In short, the gateway receives radio wave signals from the satellite. On the last leg, the return or upstream payload carrying the requesting or originating from the user's end site. The satellite modem at the gateway location demodulates the incoming signal from the outdoor antenna into IP packets and sends the packets to the local network access server. Gateways manage traffic transported to and from the internet. Once the initial request has been processed by the gateway server, sent to and returned from the internet, the requested information is sent back as a forward or downstream payload to the end user via the satellite, which directs the signal to the subscriber terminal. Each gateway provides a connection to the internet backbone from the gateway beams it serves. The system of gateways comprising the satellite ground system provides all network services for satellite and corresponding terrestrial connectivity. Each gateway provides a connection to the Internet backbone for the gateway beam it serves. The system of gateways comprising the satellite ground systems provide all network services for satellite and corresponding terrestrial connectivity. And each gateway provides a multi-service access network for subscriber terminal connections to the Internet in the continental United States. Because it is north of the equator, all gateway and subscriber dish antenna must have an unobstructed view of the southern sky because of the satellite's geostationary orbit. The gateway antenna can stay pointed at a fixed position. So everyone, I'll leave it there today for this video on broadband technologies. If you like this video, please like and subscribe. Thank you.